writing and balancing of a chemical reaction. A chemical equation is an expression that uses chemical formulas and other symbols to illustrate what reactants constitute the starting materials in a reaction and what products are formed. Now, here look at this arrow. On the left side, of the arrow, these are the reactants, and on the right side of the arrow are the products. So what are the reactants? Methane and oxygen, CH4 and O2 are the reactants. What are the products? CO2 and H2O are the products. Now I'm going to put these numbers on the front, and I'll let you know how to write down these numbers later on. These numbers are known as coefficients. Now coefficients show the number of molecules of a given element or compound that react or are formed. For example, in this one, 2O2 means 2 molecules of oxygen. 2H2O means 2 molecules of water. If no number is written, like in front of here and here, if no number is written, it's assumed as 1. So how do we say that? 1 molecule of methane reacts with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water. So this is the way you read the equation. Now here, why are these coefficients used? Because all chemical reactions follow a fundamental principle of nature, which is law of conservation of mass, that atoms are neither created nor destroyed, which means that here on you will see that you need to have the same number of atoms of each element in the reactant as the number of atoms of each type in the product. So what does it mean? For example, let's practice writing some equations and then balance them. For example, if the question is represent combustion of methane in an equation form. Combustion means burning in air. Methane is CH4, combustion is plus O2, and the products of combustion are carbon dioxide and water. If you look in this one, we have not created any new atom. On the reactant side, we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. O2 means 2 oxygens. On the product side, we have 1 carbon, we have 3 oxygens, 2 here and 1 here, and 2 hydrogens. So if you look, we have the same atoms on both the sides, but according to the law of conservation of mass, the number of atoms of each element should be same on both the sides. So how are we going to make them equal? That's by putting the coefficients. Remember, for balancing, you can put the numbers here on the front, but you cannot change these subscripts, because changing subscripts means you're changing the formula of the compound, which will not be correct. So the rule is always balance hydrogen and oxygen at the end. So for example, let's balance carbon first. 1 carbon, 1 carbon, both are balanced. So carbon is done. Then let's look at hydrogen. We have 4 hydrogens on the left side, and we have 2 hydrogens on the right side. So what we're going to do, we're going to put 2 here on the front. You can put only the coefficients, you can put the number only on the front, you cannot put anywhere else. So does that make hydrogen same? Yes, because 2 times 2 is 4. Now by putting this 2 on the front, you change the number of oxygens here, because the number on the front is for each and every element. So now this made it 2 times O, 2O, and we have 2 here, 2 plus 2, 4. So we have 4 oxygens here. On this side we have 4 oxygens, on this side we have 2 oxygens. So if I put 2 here, then now oxygen is balanced too. So look at one more time, 1 carbon, 4 hydrogens, 2 times 2, 4 hydrogens, 2 times 2, 4 oxygens, 2 here and 2 here, 4 oxygens. So the equation is balanced. So let's take one more example. I'm going to take one combustion example only, because you know how to write down the products. So that is, for example, C2H6O. Now, what are the products of combustion of C2H6O? C2H6O is an alcohol, it's an ethanol. So when combustion means O2, and products are CO2 and H2O. We're going to start with the balancing of carbon. So if balance, how many carbons on this side? 2. How many on this side? 1. So let's put 2 here. This way now our carbons are balanced. Let's look at hydrogen now. Let's look at hydrogen. So here 6 hydrogens on this side and 2 hydrogens on this side. So how can you make hydrogens equal? So 6, if I put 3 here as a coefficient, then 3 times 2 is 6. So hydrogen is balanced. Now let's do oxygen now. Now how many oxygens are on the right side? Let me erase the rest of the part so that you can see it clearly. I know, C2H6O. So there are, let's say on this side, 2 plus 2, 4 are here, and plus 3 on this side. So 4 plus 3, 7 oxygens here. How many are here? 2 plus 1, 3. Now think about it. So let's say if I put 3 on the front here, so that will make it 3 times 2, 6, plus this 1, that will make it as 7. So here, how do you read this? Ethanol on combustion forms carbon dioxide and water. Now 1 molecule of ethanol, no number means 1, reacts with 3 molecules of oxygen to form 2 molecules of carbon dioxide and 3 molecules of water.
Made with Doodlecast Pro.